We have seen inequalities before, but most of the time they've been linear inequalities, meaning it's something that looks like x plus 3 is greater than 5, right? And what we would do is we would then say, okay, so that means x is greater than 2. We plot this on a number line. Because it's greater than, not greater than or equal to, it gets an open circle, and we have this region, and the answer then, the solution, is then given as an interval, and starting this year, we're writing that in interval form. What we're going to do today is the same situation. However, the inequalities that we're going to look at, the equations that we're going to look at, are not going to be linear equations like this. They're going to be nonlinear equations. So if we take polynomials, what the inequality rather is going to look like is it's going to be f of x, and it's either going to be less than 0, f of x greater than 0, f of x less than or equal to 0, or greater than or equal to 0. Now, what does that mean conceptually, that f of x is greater than 0 or less than 0? Here, you have a function, f of x, and it's been graphed for you. Here is the x-axis. Okay? Now remember, f of x is another word for y. Okay? So if f of x is greater than 0, it means y is greater than 0. The x-axis divides the region vertically into all the positive y's and all the negative y's, right? So whatever is above the x-axis is positive, and whatever is below the x-axis is negative. So if we take this graph, for example, this part of the graph is above the x-axis, right? That means it's positive. This part of the graph is above, so it's positive. So here, the green parts that I've highlighted are the regions where f of x is greater than 0. Okay? When we talk about this, we talk about the interval. So I say, all right, between here x is negative 2 and here x is positive 2. So between negative 2 and positive 2, the graph is positive, right? From negative infinity to negative 4, the graph is positive. So f of x is greater than 0, where? At negative infinity to negative 4 and negative 2 to 2. Well, where is the graph negative then? Going with this, the graph would be negative in this region here. And here the graph is negative, and there the graph is negative, right? Anytime the graph is below the x-axis, it is said to be negative. So we say, okay, f of x is less than 0, where? Between negative 4 and 2. Right. Negative 4. So the graph is negative between negative 4 and negative 2. And again, from 2 to where? Positive infinity. All right, so do you see what we're doing? We did this based on the graph. But we're not going to have the graph when we do these equations. We're going to have just the inequalities themselves. So we have to do it algebraically. Okay? In math, there are always 3 ways to solve a problem. Graphically, which is this. Algebraically, which is what we're going to do. And the third is numerically, which you can literally, you could sit there and just plug in all the numbers from negative infinity to positive infinity, see where you get a positive value and see where you get a negative value. Not the most time efficient. But no matter what problem you're solving in math, there's always 3 approaches. So if you're ever on Jeopardy and they say, you know, name 2 out of the 3 ways to solve a problem, the 3 are numerically, graphically, and algebraically. All right? And I want credit on the air if you ever get that problem, get that one right. Yeah. All right. So One of these days, somebody is gonna give me credit on Jeopardy. I'm waiting, huh? I know. If only Jeopardy only consisted of like math and science questions. I get those all the time. But then there are others which history I'm actually not bad at. There are like these weird things like, how many legs does, I don't know, like this weird animal that I've never heard of have, like, or an insect. Well, I mean, like when it comes to insects, it's like.
Well, insects all have 6.
Okay. And if I get that question right, I'll credit Zach Rubiner. All right, so here's the plan of action when we are solving polynomial inequalities. First, we're going to solve f of x, okay? We're going to plot the zeros on a number line to create what we call a sign chart. And then we're going to test values from each interval.
It has nothing to do with, like, trigonometry, right? The sign chart?
No.
Wait, and this, is the order listed? Or
yes.
Can you go about any order?
No. This is the order. Okay, so first, we're going to solve f of x here. That means I'm going to bring 1 to the left side. So it's going to be x squared minus 8x plus 16 less than or equal to 0. Plus 15. Now we factor this. And what are we going to get? X minus 3, x minus 5. Now, from this, if we solve x minus 3 equal to 0, what number do we get from it? X is 3, right? And what does this parenthesis give you? 5. So for a split second, I'm going to forget about the inequality, all right, just for this step. So here we have 3 and 5. Now we have a number line, 2 numbers on the number line, which we extracted from the equation, all right? How many regions have we divided the number line into? Okay, so now what we're going to do is we're going to test the 3 regions. The way we do that is pick any number from each of the regions and plug it into this equation. Okay? So, take a random number.
Isn't this part freedom? Yeah.
Right. Take a random number from each region to plug into equation. All right, so from this region, okay, less than 3, I love 0. Okay, so whenever I can, I plug in 0 because it's the easiest case. So when I plug in x equals 0 into here, okay, do I get a positive or a negative value? Positive. So here in this region, 0 was from here, right? I say plus. This is my sign chart, all right? Now, from the region 3 to 5, what number can we pick? You can, of course, pick 3.675. I'm going to pick a random 4. You just plug 0 into here. 0 minus 0 plus 15, it gives you a positive result.
Does it matter actually what number you get?
As long as it's inside the region, any number starting at 3 and ending at 5 should give you the same sign. Okay? I don't care what the value is, just the sign. Okay, so we're going to plug in x equals 4 into here. What do you get when you put x equals 4 in there? Now look, because this and this are the same, you could also put 4 into this step here. So 4 minus 3 is 1. 4 minus 5 is negative 1. So you're going to get negative. Okay? And then the last one, we're going to plug in, I don't know, 10. I like 10 because it's a round number. If I put 10 in the first parenthesis, I get a positive number. Here I get a positive number. That means it's positive. So this is now my sign chart. Now, the equation, right, was asking me for less than or equal to 0. Less than or equal to 0 means the negatives, right? So in this chart, in which region did we get negative values? In here. So my answer, because it's less than or equal to, is from 3 to 5 inclusive. So my solution is 3 to 5 in brackets. All right, so that's how I do this. If this is less than 0, it's where it's negative. If it was greater than, it would be where it's positive. All right, so let's do another one here. This is a cubic equation, which is fine. So we're going to say x cubed minus 3x squared minus 22x plus 24 is greater than 0. Now, if you can, you factor by grouping. This one cannot be factored by grouping. So how do we solve an equation that can't be factored? P over Q, synthetic division. All right? So let's go. P over Q is going to be plus or minus 1, 2, 3, 4, 6, 8, 12, 24. Have I missed one? All right, so let's do synthetic division with 1. 1, negative 3, negative 22, 24. Negative 2, negative 24, negative 24. Hey, it works. All right, so x minus 1 times x squared minus 2x minus 24 is greater than 0. And I can totally factor this now. So I factor this. X, brownie points to the first one. 4 and minus 6. Okay, any factoring questions? You can ask Brooke. So from here, what values do we get to put in our number line? Right, 1. Yeah. So it's 1, negative 4, and 6. So it's negative 4 here, 1 and 6. It helps to put the numbers in order on the number line. Now we have 4 regions. Okay? All right, pick a number below negative 4. Let's say negative 5. And again, you can put it in each of the parentheses here. Okay? So if we put negative 5 into this parenthesis, we get a negative value, a negative value, a negative value. That's 3 negatives makes negative. All right, between negative 4 and 0, I'm sorry, 1, there is 0.
So wait, if there's 3, wait, there's 2 positive
Then it's negative.
Wait, negative 5?
Whatever the signs multiply to.
Oh, okay.
So if you put 0 in here, right, when it's 0, I like to put it into this one because it's easiest, right, into the top one. You get positive. Between 1 and 6, what number do you guys want? 2. If I put 2 in the first parenthesis, I get positive. In the second parenthesis, I get positive. In the third parenthesis, I get negative, so total, that'll be negative. Greater than 6, 10, 7, all right, we'll do 10, I like 10. So 10 in the first parenthesis gives me positive, then another positive, then another positive, total positive. Now, my question was asking for greater than 0. That means I want the positives. So this region and that region.
So you just do
Now, It's between -4 and 1, but because it's not greater than or equal to, I have parentheses, not brackets, union 6 to infinity. That's the answer. Now, I have a little secret for you. Don't tell anybody. Here's where multiplicities come in. Okay? At each 0, check the multiplicity. If the multiplicity is odd, what does that mean? That means, like at -4, if the multiplicity is odd, the graph is going to cross the axis. That means before it, it was negative. After it, it's positive. So if the multiplicity is odd, then the sign will alternate at that 0. Negative, positive, positive, negative. Okay, let me finish. If the multiplicity, here the multiplicity is odd, and here the multiplicity is odd. Right? So just taking -4, so you just do one interval, like the left one. You got negative, right? Now, if the multiplicity is odd here, that means it'll alternate to the other side. So now that makes this positive. Now, look at this one. The multiplicity is odd. That means the sign will change from here to here. That makes that negative. Now look at this one. If the multiplicity is odd, that means the sign will change from here to here. That makes that positive. So essentially, the only number I could plug in is, I could just plug in one of them, and I could fill in the sign for the rest. Okay? If I were doing this for myself, here's what I would do. The easiest number for me to plug in is 0, right? Where does 0 live? Between -4 and 1. I put 0 in here and I get positive. So now, going this way, it's going to alternate, so that's going to be a minus. Going this way, it's going to alternate, so minus, alternate again, plus, and I'm done. Because, look here, multiplicity 1, right? Because all of these exponents are 1.
Wait, would all
Okay? No. It doesn't change anything. It makes it easier for you. Okay?
I'm confused how 0 was a positive when you plug in 0.
Well, what do you get when you plug in 0 into this? Positive 24.
Oh, you're plugging it into the original. I thought you were plugging it in.
Either way, if you plug 0 in here, you get negative, positive, negative. Negative, positive, negative. That's two negatives. It makes it positive. Okay?
So it doesn't matter where you...
This is another one. Can we factor this one? No, it can't be factored. If it can't be factored, you're going to do p over q, but if it's a quadratic equation, we do the quadratic formula, right? So x is equal to negative b, which is -2, plus or minus the square root of b squared minus 4 times a times c over 2a. So x is equal to -2 plus or minus the square root of 4 minus 12 is -8 over 2, -2 plus or minus 8 is 2 root 2. And because there is a negative inside, you have an I, so it's 2i root 2 over 2. Now, I have to simplify this. If you don't, points off, right? So, if you can divide all three of these by the same number, then you must. All three of these can be divided by 2, so finally, x is -1 plus or minus I root 2. Now, quadratic equations means I have two solutions. I got two solutions, both of which are imaginary. Now, listen carefully to this part. Because my solutions are imaginary, I have no real numbers to put on a number line. But in order to solve this, I need to look at a number line. What I do in this case, I create a makeshift number line. Okay? And I want to put a number on there. the most common sense is to put 0 in here. So just put 0. Now what you want to do, so basically there are no real solutions to put on the number line. What I do is I need to examine my function, okay, with respect to the number line. All right, so here's how you do this. There's a little bit of mental math involved here, okay, a little bit of visualizing. All right, look at the negative numbers, okay? Suppose you put a negative number in there, and you know what? Maybe we can test a negative number. Let's just pick -1. If I put -1 into my equation, I get -1 squared, which is 1, minus 2 plus 3. Is that positive or negative? Positive. If I put -10, believe me, it's still going to be positive. Okay? Well, what if I put 0 in there? If I put 0, I still get positive. What if I put a positive number, like 1? It's going to be positive because if you have a positive number, which you square, and then you add positive stuff to it, it's going to be positive, right? So what does that tell you? No matter what number I put in here, the graph is always positive, right? So graph is always positive. That means I get positive here, I got positive at 0, I got positive after 0. All right, but what is my equation asking me for? My inequality is asking me for the region where this is less than 0. When is this ever less than 0? Never. That means it's no solution. Okay? Okay. Now, here I have the same function for d, but this time it's greater than or equal to 0. So let me listen to what I have to say so everybody can hear me. It's the same exact graph. Okay, it's the same exact equation. Again, it's here we have 0, we have positive here, positive, positive everywhere. It's asking me for the area where it's either greater than 0 or equal to 0. Where is it equal to 0? It's never equal to 0, but where is it greater than 0? Everywhere, okay? The solution to this is all reals, because everywhere on the graph, it's either greater than 0 or equal to 0. It has to be either or. So the solution is -infinity to +infinity, since it's positive everywhere. That's what C asked for. Right? So, like, you could have... if it was negative, there would be no solution. Just like C, the opposite of C. Okay, so here's another one. This one factors, yes, this one factors like this, x plus 6 squared less than or equal to 0. Okay? Now, from here we get that x equals -6, right? So I put -6 here. Now, if I pick a number below -6 and put it in here, I get positive. If I pick a number above -6, like 0, and I plug it in here, I get positive. What do I get at -6? If I put -6 in there, what do I get? 0. Now, this equation is asking me for less than or equal to 0. Where is this less than 0? Never. Where is it equal to 0? At -6. So the solution to this is always -6 only. Okay, so listen, one more time. We want it either less than 0 or equal to 0. it's never less than 0. Is it ever equal to 0? Here, it's equal to 0. So my solution is just -6.
And we ignore the,
We put it in curly brackets, or you could just say x equals -6. It's the same. Okay? All right. Now, rational inequalities are the same. The only difference is that the sign chart of a rational inequality must also include the zeros of its, and here I have a typo, it should be denominator. Okay? So we must also include the zeros of the denominator. The zeros of the denominator are the asymptotes, right? Vertical asymptotes. So look at what happens here at the vertical asymptotes. At the asymptote, on one side, the graph is negative. On the other side, the graph is positive. So there is a sign change at the asymptote and at the zeros, right? Where does the graph go from negative to positive? At the asymptote. And also at the zero, it goes from positive to negative. So we have to look at asymptotes and zeros. Okay. All right, so here, to solve this one, just like we were doing in section 5, right? We multiply both sides of this by x plus 2. This is like a very simple one. So we get 3x plus 4 greater than or equal to 0. So for x, we're going to get -4/3, right? Now, I put -4/3 on the number line. Well, how much is -4/3? It's -1 point something. But I also put in the 0 from the denominator, okay, which is -2. That's the difference between rational functions and not. Now I'm going to do the same thing. When I plug in my number, in this case, I can only plug it into the very, very original equation. All right? So I plug in numbers to this. Into original equation. All right? So if I pick -10, on the top, that gives me a negative number, right? It's like -26 or whatever. What about on the bottom? What do I get on the bottom? A negative number. So together, that makes positive. Now, at the -2, is the multiplicity odd or even? Odd, so it's going to be negative here. No, because not -2, like between -2. Okay, at -4/3, odd or even multiplicity? Odd, so it's going to switch from negative to positive. Okay? If you're not comfortable with that, put numbers in there and test values. Totally the same. 0. I'm sorry, if you plug in -1.5, right? If you plug in -1.5 to here, you get positive and negative. Like it'll be negative. Okay? You get negative on top, positive on the bottom. Okay. Now, I needed this to be greater than or equal to 0. Okay? Now, are there any restrictions here? X cannot be -2. Now, where is the graph positive? Because I want the positive values. Here and here, right? So here, it's -infinity to -2, open brackets, because it can never be 0. Well, the denominator can't be 0, so you can't have -2. Union, in closed brackets, -4/3 to infinity. All right?
Wait, go back up.
Okay. So what I will do is, after this class, I will continue the screencast for part B, and I will put up the screencast. Your homework, which is this, is due Monday? Monday.
Can I read the problem also? The last problem on the last.
Will you like talk during it?